This video is part of a series of videos on coordinate geometry and the conic sections. Write the equation of a circle with center located at -4, 11 and containing the point 5, 2. So I quickly sketched an xy coordinate plane for us to look at this problem. So we have the center of this circle is at the point -4, 1. This is the line -4. I'm sorry, -4, 11. So we're way up here at the center of this circle. And this circle contains the point at 5, -1. So if we're thinking about this, of all the points that are on the line, 1, 2, 3, 4, 5, this point is certainly one of the points that's on the line. So if you can imagine, this line here would be a radius of this circle, and we have, a very large circle going off in both directions. And I don't think I'm going to do a good job of sketching a circle here. But that's the circle, and I guess the piece of information that we're really missing here is we don't know how big the radius of this circle is. And if we knew that, using the distance formula, or actually just using perhaps the memorized equation of a circle, we could write down the equation of this circle. So let's go ahead and use the distance formula. Speaking of it, I guess we could use it twice in this problem. Let's use the distance formula to find out how far it is from the center of this circle way over here to a point that is on that circle. If you're thinking about the distance formula, remember it's just an application of the Pythagorean theorem. We have here this not so hidden but hidden right triangle. The length of one of these sides is 12 units long. If I go from 11 all the way down to -1, I travel 12 units. And if I go from -4 all the way to 5, I travel 9 units. So I know the dimensions of this. And of course the radius then would be, according to the Pythagorean theorem, it should be equal to the square root of, radius square would be this, but if I'm just writing down the radius, it should be 12 squared plus 9 squared, and that of course is 144. Oops, too many 4s there. It's 144 plus 81, which is the square root of 225. And the square root of, let me check this, square root of 225 is equal to 15. So I have a radius that is 15 units long, all the way from the center all the way down to this particular point here, traveling 15 units. And I also know the center of this circle is at -4, 11. Since we just used the distance formula, I'm just going to go ahead and use the equation of a circle to write down the equation of a circle, right? And I'll just put it here for reference. So the equation of a circle centered at HK is x minus h quantity squared plus y minus k quantity squared equals the length of the radius squared. So for this particular problem, I have x minus h. Since h is -4, I have x minus -4, which is plus 4, and that's squared, plus y minus 11 squared, and that equals the radius, which we decided was 15 is the radius squared, which is 225. So plotting this result in Geogebra, this is the circle I have. It's a pretty large circle. And the one thing I want to verify is that does it really include the point 5, -1? So in GeoGebra, and it's just slightly off screen, I think I can pull this up so you can see it. Right there's the input panel. And I'm just going to go ahead and bring up GeoGebra's on-screen keyboard, and I'm going to ask it to plot the point 5, -1. And when I plot that point, I am very pleased to see that it indeed, it certainly appears to be on that circle. So again, we were able to find the equation of a circle that was centered at -411 and contained the point 5, -1.